In this video, I'm going to solve some question based on MCQ question that is based on circle, class 9. The first question is says the angle formed by a minor segment. So let's first make a circle. Let's say I have drawn one circle here and they're talking about the minor segment. So clearly, let's make a chord first. Let's say this is a chord AB. Need to figure out which is the minor segment here. So you can see from the figure, the minor segment is supposed to be, minor segment is this. Is the minor segment that is smaller than semicircle. Now, they are not asking angle subtended by a minor segment. The question is angle formed in minor segment. So it's different thing, right? So here they mean to say that the angle over here, that means they are talking about this angle. Let me show you. This is the angle they are talking about, right? So we can just figure out also that this is actually more than 90 degree and it will be an obtuse angle. The other reason you can provide is that you can see that here the segment is minor, but the arc through which it is made, this is actually major arc, which is making an angle on the minor segment, and it has to be more than 90 degree. So two things you can figure out. Whenever an angle is made on the minor segment, it is more than 90. And if it is formed on the major segment, like say, for example, if I make an angle over here on the major segment, you can see it is forming an acute angle. This angle is going to be an acute angle. Further, you can also figure out that if it is a semicircle, right? If it is a semicircle, let's say, for example, I erase things. As if it is the semicircle, that means considering this to be the diameter, in that case, it is 90 degree. So over here, the question was in the minor segment, and we saw that in the minor segment here, in the minor segment, the angle made is obtuse. In the next question, it says that the number of circles that can be drawn through three non-collinear points. So it means to say, if I take three non-collinear points, say 1, 2, 3, how many circles we can draw, right? So let's figure out, if you try making a circle so that it is passing through three non-collinear points, let's say I make a circle here, let's say I made a circle, and then I took three non-collinear points and try figuring out how many circles can be drawn through these. So you'll observe that not more than one circle can be drawn through three non-collinear points. So a unique one circle can be drawn. So the correct answer is 1. Through non-collinear points are what? 3 points which do not lie on the same line. Like if I say these 3 points, I can say they are collinear because a straight only they lie on a straight line, right? They lie on a straight line. And when we talk about non-collinear points, we mean to say that they do not lie on a straight line. So we can say the number of circles that can be drawn through three non-collinear points has to be 1. In the next question, it says there is a figure given here with O being the center of the circle and angle BAO. This angle is given as 68 degree. This angle is 68 degree, and AC being the diameter of the circle. We have to find the measure of angle BCO. That is, BCO is this angle. Well, we should know that this is AC is the diameter, so we can use the property angle in a semicircle is right angle. So this angle will be 90 degree. That is angle in a semicircle. Now you can use angle sum property. That means, say if I take this angle as x, so x plus 68 plus 90 is equal to 180 degree. So we can say x is equal to 180 minus the sum of this, which is 158. So this angle is 22 degrees. So this is the correct answer. So property used here is 2 of them. One is angle in a semicircle is right angle. How do we find out it is angle in a semicircle? Whenever it is subtended by the diameter, the angle subtended on either side, can be this side also, it is always 90 degree. Anywhere on the circle is always 90 degree. And the second property we use that sum of three angles of a triangle is 180 degree. Another question based on angle in a semicircle is said a chord of a circle of radius r. As of now, we do not know whether this chord is the diameter or not. So let's say I have made a circle first and the radius is mentioned r. Further, it says there is a point P. Let's say I take a point P over here. I took a point P anywhere on this circle. I took this point as P on this circle such that angle APB is a right angle. So APB, let's say I took a point A here and say B here. And if I make the angle subtended by this, that means angle APB, which is given to us as 90 degree. As for the information, it is a right angle. What do we know? That angle in a semicircle is right angle. We know from the property that angle in a semicircle is right angle. So clearly, AB has to be the diameter of the circle, right? And if AB is the diameter, we can say O be the center, and this is R and this is R. So the length of AB, clearly, diameter is always twice the radius. Once again, we are given a point P and the angle subtended by AB is mentioned that it is 90 degree. So angle in a semicircle is right angle. So by default, we can say AB is that chord which is passing through the center, or in short, we can say AB is the diameter. And if AB is the diameter and R being the radius, diameter is twice the radius. So 2R is the correct answer. In the next part, we are given a chord A, B, and CD. And you can see the chord A, B, and CD are intersecting at this point. Further, it says angle BAC. This angle is given as 40 degree. And we have to find this angle, that is ABD, right? So first of all, you need to see that this angle, that is 40 degree, which is given, is made by this arc, right? So using the property angle in a semicircle, angle in the same segment are equal. So this angle must be equal to this angle. And the reason is angle in the same segment are equal. So we can say that this angle will also be 40 degree. So this is 40 degree. And from linear pair, we can say this is 90 degree. As you know, perpendicular makes an angle of 90 degree on either side. So this is 90 degree. If this is 90 and this is 40, so we can apply angle sum property in this triangle. That is, I mean to say this triangle. In this triangle, we can apply angle sum property, that is sum of three angles of a triangle is 180 degrees. So applying this property that sum of three angles of a triangle is 180 degrees. So the third angle will come out as 50 degree, right? Because this is 90 plus 40 is 130 and 180 minus 130 is 50 degrees. So C is the correct answer for this question. Now the next question, we can see there is a figure given. It says OA is equal to 5 centimeters. So OA, I'm marking 5 centimeter. Clearly this is the radius of the circle. Further it says AB, the length of AB is given as 8 and OD is perpendicular. So this is 90 degree, right? This angle is 90 degrees, will be perpendicular. Then CD is equal to, we have to get the length of this CD. We have to get the length of this CD. Now, first of all, you can see that the first property I can write is AO and OD are nothing but the radii, right? They are equal to the radii, their radius only. So since one is 5, OA is 5, OD will also be 5. I repeat what I mean to say that this length, OD is also the radius, so I mention it 5. Now, the next thing that you have to see that whenever a perpendicular is drawn from the center, it bisects the chord. Perpendicular drawn from the center. Whenever a perpendicular is drawn from the center, so it will bisect the chord. Means to say AC must be equal to BD. We already know the length of AB, AB being 8. So can I say that AC will be 4 and BC will also be 4. The reason is perpendicular drawn from the center bisects the chord. So we have AB as 8. So clearly AC and BC are equal. So they will be 4 each. Now, this being a 90 degree, we can apply Pythagoras theorem, or we can use that property Pythagorean triplet. Look into this triangle. Here in this triangle, what you can see that this is a right angle triangle. This is a right angle triangle where we know the length of the hypotenuse. The length of the hypotenuse is given as 5 here, and say one of its sides, one of its leg is 4. So using Pythagorean triplet, I can say the length of OC is equal to 3 centimeter. Now let's figure out once again what we got here. OC we got as 3 centimeter, and we already know the length of OD as 5. We know this length is as 5 centimeter. So this length, that is CD, will give you 5 minus 3, that is equal to 2 centimeter. So this is coming as 2 centimeter. The property used here is number 1, perpendicular drawn from the center bisects the chord. And the second property that we used is Pythagorean triplets. That is, in a right angle triangle, the square of the hypotenuse is equal to sum of the squares of other two sides. Now we are on the next question. It says ABCD is a cyclic trapezium. So two things is, one is ABCD is a trapezium, and moreover it is cyclic. That means cyclic means here all the 4 vertices, that is ABCD, are on the circle, not inside or outside. They are on the circle. And further, we know the value of one angle, that is angle B is given as 60 degree. And what we have to find out is angle BCD. This is the angle we have to find out. Now, the property we are going to use is one, that is opposite angles of cyclic quadrilateral are supplementary. So clearly angle B plus angle D should give you 180 degree. As we know the value of B, which is 60 degree. So we can get the value of angle, it is D, right? B plus D is 180 degree. This is opposite angles of cyclic quadrilateral are supplementary. So clearly angle B is known to us. So we'll get angle D as 180 minus 60, that is 120 degree. So we got this angle as 120 degree. Further, the next thing that we are going to use is the property that co-interior angles are supplementary. You should know that interior angles on the same side, like this line is given parallel to this line, considering DC as the transversal. What you should know that the sum of these angles, that is this plus this, should be 180 degree. Reason, they are co-interior angles. I repeat, co-interior angles are supplementary, and that is true when the lines are parallel. As you can see here, AD is parallel to BC, that is already mentioning. We have this AD parallel to BC. So we can say that angle D plus angle C is equal to 180 degree. As we know the value of D as 120, so 180 minus 120, that means angle C should be 60 degrees. So this angle, the one which they have asked for, is 60 degree. In the next question, we are given a straight line, that is APBQ is a straight line, and is drawn to cut two concentric circles. Now, what are two concentric circles? Circles having the same center, right, with a different radii, obviously different radius, are called concentric circles. So you can see this circle and the outer one, they have the same center. Now, what we have to find out is which of them is correct, like AP being greater than BQ. That means we have to get a relation between AP and BQ. Now, this question is there in your textbook in CRT. Let's say the property on which it is based is perpendicular drawn from the center bisects the chord. So you might have done this question if you have done textbook. Let's say if I consider this point, let's say I consider this point as M. So since perpendicular drawn from the center bisects the chord, now consider the outer circle. In the outer circle, we can say AM is equal to BM, as AB is the chord and OM is perpendicular drawn from the center, and perpendicular drawn from the center bisects the chord. Now consider the inner circle here. In the inner circle, PQ is a chord So using the same property, I can say that PM is equal to QM, right? And if you subtract these two, like that is AM minus PM is equal to BM minus QM. So clearly the difference is coming AP, and the other side it is BQ. So what we can see that AP is equal to BQ is the correct option for this. We are on the next question. It says AB and BC. AB is 12, BC is 16, and AB is perpendicular to BC. So let's make a line segment AB and the other line segment slightly bigger. And that is, I'm marking this point as say A, B, C. I made it perpendicular. That is what mentioned that AB is perpendicular to BC. Then they're asking what will be the radius of the circle passing through these 3 points A, B, C, and D. So let's say if I make a circle that is passing through these 3 points. So I'm going to draw a circle passing through these 3 points. Now, let me expand it. Even if it does not look like a circle, that is, you don't have to make up to the scale, to the scale by that I mean to say. So now I've drawn a circle. Now that is passing through these 3 points, and then we have to find out the length of AC. Now what you can see that since this angle is given as 90 degree, so by applying the property that is angle in a semicircle is right angle, we can say that AC is nothing but the diameter, right? This is diameter. Now, next we have to get is the length of the radius, right? The radius. So first I can see that the length we know, what are the lengths we know here? We know the length of AB, as say this is 12 and this is 60. So we can apply Pythagoras theorem in order to get the length of AC, that is AC square is equal to 12 square plus 16 square. This is 144 and this is 256. That is equal to 400. So AC square is equal to 400. That implies AC is equal to 20. So now AC is 20. So clearly AC is the diameter. That is important to know that AC is a diameter. And the reason is angle in a semicircle is right angle. Now, if AC being the diameter and if its length is 20, you know that the radius is half the diameter. So radius will be 10 centimeter. That is this. In the next part, you can see there is a figure given and we have to find the measurement of this angle, that is X. What you need to see that this angle is actually subtended by this arc AC, right? And AC is subtending an angle at D, and that is X. And the same arc AC is also subtending an angle at the center. So we must try to find out this angle, and then we can use alternate segment. Now, what I can see that it is AB is a straight line. So clearly this is forming a linear pair. So we can say that the angle AOC, that is angle AOC, will be equal to 180 minus angle, that is 110. We can straight away write this as 110 as an MCQ. No need to write down the steps. So we got this angle as 70 degree. Now you can see that the angle subtended, this angle is subtended by this arc AC. This arc AC subtending an angle at the center and whose value is 70 degree. By using alternate segment, which says that angle subtended by an arc at the center is twice the angle subtended by the same arc on the remaining part of the circle. So this X should be half of 70, that is 35 degree. Based on the property called alternate segment, the property says that the angle subtended by an arc at the center is equal to the angle subtended by the same arc on the remaining part of the circle. And that's why we say on the remaining part, that means this will be equal to half of 70, that is 35 degree. In the next question, we are given a figure where we know the measurement of this angle, that is BAC, that is given as 25 degree, and we have to get the measurement of this angle BOC. Now, that's a very easy question based on directly that this angle is actually, that is the given angle BAC is subtended by this arc BC on the circle, and the same arc is subtending an angle at the center. So what do we know? That the angle subtended by an arc at the center is twice the angle subtended by the same arc on the remaining part of the circle. So this will be equal to twice of 25, right? This angle, the angle which is made at the center, is twice the angle subtended by the same arc on the remaining part of the circle. So we can say that by using alternate segment, this angle will be equal to 50 degree. We have another question based on angle in a semicircle. Let's see what does it says. It says the figure drawn here, and we are given the measurement of angle ADC. You can see this angle ADC is this, right? This is angle ADC. Its measurement is given as 118 degree. This whole angle ADC is 118 degree. Now, what do we know? That AB is a diameter. As you can see, it is passing through the center. So chord passing through the center by default has to be the diameter. So angle ADC will be 90 degree, right? That is angle in a semicircle is right angle. So this angle will be equal to 90 degree. So we know the value of this whole angle as 118 degree as for the given in the question, that this angle ADC, this whole angle is given as 118 degree. So the remaining angle part, and that means this one, right, will come as how much? It should be 118 minus 90. That is 118 minus 90 degree. So that will give you the value of this angle, and that will be 28. So this is the B is the correct option. We are on the next question, MCQ, that is ABCD is given a parallelogram. I can clearly see that ABCD is already given a figure and it's a parallelogram. Further, it says that a circle is passing through these 4 points A, T, F, and E. And it is also mentioned that this exterior angle, right, is given as 80 degree. And we have to determine this value of this angle, that is PEF. What we have to determine? Oh, sorry, we have to determine EVC only, right? Measurement of BEF is given 80 degree. Now, what I'm going to use here, first I'm using linear pair. I can find the value of this angle. So you can see in this figure, once again, you can see this is a straight line. So clearly the sum of these angle will be 180 degree. So if you know the value of this as 80, then I can say value of angle AEF will be 100 degree. This should be 100 degree. Now check for this. This is a cyclic quadrilateral. I am drawing once again the cyclic quadrilateral. That is, this is given a cyclic quadrilateral. This is a cyclic quadrilateral. Why should I say it's a cyclic quadrilateral? Because all its 4 vertices are on the circle. So if this angle is 100 degree, right? So the opposite angles of cyclic quadrilateral are supplementary. So I can say the value of this angle, that is this angle, that is ADF. Angle ADF will be 80 degree. Why so? Because opposite angles of cyclic quadrilateral are supplementary. So if this is 100, this will be 80. Now consider the other information which is given in the question. Once we get this angle, check for this. We have ABCD is given a parallelogram. This figure ABCD is a parallelogram, and opposite angles of parallelogram are equal. Do we know that opposite angles of parallelogram are equal? So I can say that angle B will be equal to angle D. Angle B should be equal to angle D, and D being 80, so B will also be 80 degree. The next question, which is based on equilateral and property. It says a chord of a circle is equal to the radius of the circle, there is a chord which is equal to the radius. So you should always remember, whenever a chord, the length of a chord is equal to the radius, it is always an equilateral triangle, irrespective whatever is the other information given. So here this chord is equal to the radius. So we can say that it is an equilateral triangle. We can name it, say, for example, if I name it AB and center being O, so clearly AOB is an equilateral triangle. And we also know that each angle of equilateral is 60 degrees. So this will also be 60 degrees. Now, if I read the later part of the question, they are saying angle subtended by this chord in the major segment. Well, we can figure out which is the major segment here. This is right. This is the major segment, right? And you know that this part, this is minor segment. So they're asking the angle subtended by this chord on the major segment. So clearly the major segment anywhere here, right? Anywhere on this part, can draw anywhere. Say I draw over here. Right. They're asking to find the value of this angle. So if I mark this as P, we have to get this value. As you know that the angle subtended by an arc at the center is twice the angle subtended by it on the remaining part of the circle. You can see AB is an arc. It is subtending an angle at the center, which is 60 degree. And if the same arc subtend an angle on the remaining part of the circle, so this angle has to be 30 degree, that is half of 60. So this angle will come as 30 degrees. So we'll say that this is. Now, in case if they ask you the angle subtended by this on the minor arc, right? Then it would have been this angle. And we can say, assume this is Q. We can say PAQB is a cyclic quadrilateral, and opposite angles of cyclic quadrilateral are supplementary. So in that case, we could have calculated Q as 180 minus 30, that is equal to 150 degree. In the next question, we are given, there is a figure, as you can see, PQ and RS are two equal chords. So this chord PQ and the chord RS are given equal, right? And we also have OA and OB as the perpendicular drawn on this chord from the center. Well, very important to remember that perpendicular drawn from this center bisects the chord. At the same time, if two chords are equal, then their distance from the center are equal. So clearly we have these two chords PQ and RS as equal. Then the distance, which is OA and OB, will also be equal. Why so? Because equal chords are equidistant from the center. So we have this as 90 degree and this as 90 degrees. So we know that is PQ is equal to RS. So we can say that OA is equal to OB, and that is equal chords are equidistant from the center. We have this angle given as, how much it is given as 140 degree. And we have to get the value of angle PAB. That is PAB is, sorry, that is PAB. This angle is what we have to find out. This is what we have to find out, that is PAB. Now, first, we need to consider this triangle. The triangle I'm talking here is, let's say, this one, this triangle. Look into this triangle. We actually have, let me just first shed it. Right, in this triangle, we can do with a proper working here. That is, so this is in triangle AOB. We have OA is equal to OB, as you can see, OA is equal to OB. So as you know, in a triangle, if two sides are equal, then the angles opposite to these two sides are also equal. So we can say this angle will be X and this is X. So we can say that angles opposite to equal sides are equal. So X plus 140 is equal to 180 degree, and that is by angle sum property. So this is 2x is equal to 180 minus 140, that is 40 degrees. So now we can say X is equal to 20 degree. Now we have this value as 20 degree. So I'll erase everything. And then also what angle we have just obtained. We have obtained this angle, let's say this angle we got as 20 degree. And we have to find out this angle. Let's see this whole angle, this angle, that is, this is 90 degree, right? Because OA is perpendicular on AB. So you can say this angle is 90 degree. I should write it here. That is angle OAP is 90 degree. And we just calculated the value of angle OAB as 20 degree. So this angle, the required angle is actually difference of these two angles, that is 70 degree. So one last time I can explain this part. We have to get the measurement of this angle. We know the value of this angle from here to here as 90 and from here to here as 20. So 90 minus 20 will be the required angle, that is 70 degree.